Variables on both sides. Mark is performing a lymphoscintigraphy on a patient. This test will help him determine the function of the lymph nodes throughout the body. Use this equation to determine how much dye should be sent into the patient's lymphatic system. So we have 4D minus 10 is equal to 2D plus 12. As you can see, we have two variables, and they're on both sides of the equal sign. So let's just do a quick review. So when solving an equation, we want the variable on one side. This is our first step. If the variable is on both sides, we will move the smaller one by adding or subtracting. So let's now go back to our problem. So we will need to move 2D because it's the smaller one. So to get rid of 2D on the right hand side, we will subtract 2D. So we go minus 2D minus 2D. So 2D minus 2D is equal to 0. So we have 12 on the right hand side. Now we have 4D minus 2D, which is the same as 2D. And we have minus 10. Now we want to get the D on one side. So to continue, we will add the 10 to both sides. This gets rid of it as that equals to 0. So 12 plus 10 is equal to 22. Now we will need to do one more step. As we are multiplying, because 2 times D is a multiplication, we will need to divide. So to get D by itself, we will divide by 2. So now we have 2 divided by 2, which then becomes 1, and the D is just left. So we can just put D. Now 22 divided by 2 is equal to 11. This is our answer. Now let's go to another example. Val is measuring edema or swelling in her patient's right leg by using the equation 7x plus 4 is equal to 9x minus 22. So let us help Val solve this equation to determine the measure of the swelling. So the first step will be to get the variable on the one side. And since 9x is larger, we will move the 7x. So to move the 7x, we will want to subtract 7x on both sides. That's 7x minus 7x is equal to 0. And now we have 9x minus 7x, which is equal to 2x minus 22. Now, to get x by itself, let us add 22 on both sides. So then we are left with 2x plus 0 is equal to, on the left-hand side, 4 plus 22, which is equal to 26. So let us now do our final step, which will be to divide on both sides. So we divide by 2. And so now we are left with x on one side, because 2 divided by 2 is 1. And 26 divided by 2 is equal to 13. So this is our answer for how much there is swelling. So let's look at another example. So example 3, Cynthia's measuring the swelling and wants a more accurate number. Use this equation to determine the measure of edema, or swelling. So 2.2x minus 4 is equal to 1.1x plus 2.6. So this time now we have decimals. So let's get x by itself. So let's move the smaller one, which is this 1.1x. So we will go minus 1.1x on both sides. So this gets to 0 right here, because 1.1 minus 1.1 is 0. So now we have 1.1x minus 4. So now to get x by itself, let's add 4 to both sides. Oops, looks a little off, but minus 4 plus 4 is equal to 0, which is equal to now 2.6 plus 4. So we're really just looking at adding the ones, so we just do this. So now we're left with 6.6. So now here we are, we need to get x by itself. So let us divide by 1.1 on both sides. So now we're left with x equals 6, because 6.6 divided by 1.1 is 6. So here's our solution. Now let's look at one last one. Mark is performing another lymphoscintigraphy on a patient. Use this equation to determine how much dye should be sent into his patient's lymphatic system. So we have this equation. So we notice that 2.5 is smaller than 11.5. So let us move this one first. So minus 2.5d on both sides. So we're left with 0 plus 12. And then on this side, 5 minus 5 is 0. 11 minus 2, which is 9. So we have 9d minus 6 is equal to 12. So let us add 6 on both sides to get rid of the 6 on the left-hand side. So now we're left with 9.0d, because this becomes 0. And this is now 12 plus 6, which is 18. So in our final step, we will need to divide. So we can just divide by 9 on both sides. So now we're left with d on the left-hand side. Now 18 divided by 9 is 2. This is our final solution.